This is the video version of the final exam review if you are having trouble getting the audio slideshow going, particularly if you're using an iPhone. In chemistry, we studied combustion: wood fire, hydrogen, methane, metal, and sulfur. If you look at these equations, they're all adding O2. Carbon produces CO2, so does methane, which is CH4. Hydrogen only makes water vapor, and magnesium makes a greasy white powder called magnesium oxide. Sulfur and oxygen form sulfur dioxide, which turns into sulfuric acid when it touches water. So if you inhale it, your nose and lungs will begin to burn. The hydrogen fire is characterized by no visible exhaust because it's water vapor, while a carbon-based fire will always make a yellow smoke. Metal fires, particularly magnesium, are characterized by brilliant white. And this is why when the Hindenburg exploded, while it was full of hydrogen, it should have burned like the engines on the shuttle orbiter here, but the presence of metal and aluminum paint and rubber produced the bright white fireball that you see. Complete and incomplete combustion are important as a basic living creature that works around dangerous chemicals. This is your household furnace. Methane and oxygen burn to form water vapor and CO2. You cannot breathe CO2. It will poison you, so it needs to be ventilated. However, if you choke the air supply, like we did with the Bunsen burner, by closing the chimney, you will have insufficient oxygen to make carbon turn to CO2, and you wind up with C and CO. C is soot, but the CO is carbon monoxide, and it can poison you very quickly. The difference being it takes 10% CO2 in a room to kill you and less than 0.1% of carbon monoxide. It's like 50 times more poisonous than CO2. These symptoms are not something you need to read up on for this course. It's just extra if you want to pad your knowledge on the topic. If you want more detail, please watch my video that we covered in class about the production of carbon monoxide and carbon dioxide from an incomplete burn. Again, this is just a slide showing you more detail on carbon and carbon monoxide. A video that for some reason is off to the side will go through details of methane combustion as well from the past. Please watch the Mizuku video again about carbon dioxide from volcanic sources and the story of Lake Nyos. Those are important real-world examples of incomplete combustion or products that are asphyxiating gases. Again, 2 more on carbon dioxide because everybody's obsessed with carbon monoxide, but dioxide can kill as well. Knowing the difference between a hydrogen combustion and a hydrocarbon combustion, you can watch my video again. Magnesium was the one fire of a metal we looked at. Non-metals burn to form gases. Magnesium's a metal, and metals will tend to burn to form solids called oxides, or we nickname them rust. Magnesium burns bright white and leaves magnesium oxide behind, which is a greasy white powder. Any metal oxide, like iron oxide, which is nicknamed rust. So not all rust is red. Iron has at least 5 colors of rust. Think about it. Did you ever see a mustard color trail of rust where water drips onto bare metal? There are 4 other elements I would like you to know something about. So this is about the only knowledge part of the exam. Chlorine, nitrogen, phosphorus, and sulfur we studied because they're really cool, right? And all you have to be able to do is tell me a pro and con about one of these. Chlorine gas was used as bleach to disinfect swimming pools and our drinking water, and it made the first surgical soap for surgeons. So it saved millions of lives, but it also was the first gas warfare used in World War I. Chlorine got replaced with mustard gas and phosgene gas later on. And if you look at the formulas, you can see chlorine in both of them. You don't need to know these formulas. But the weird part is mustard gas, not only does it kill living humans, if you inject it into them, it kills cancer cells in the bone. So it turned out it became the first chemotherapy agent. So that's why I like chlorine for pros and cons, because wow, would the world be better off without it or with it? And it's overwhelmingly, chlorine has done more good than harm. Nitrogen is 80% of the air, but it really doesn't do much at room temperature. But in the pressure of a car engine, it turns into nitrous oxides, and there are many kinds, and they form acids in our lungs when inhaled. The simplest nitrous oxide is laughing gas. It's still rough on you, but it's not that bad. And it's created to this Asian brown cloud, which is a mixture of soot, basic carbon smokes, and the nitrogen, which gives it a slight orange tint to it. And we can now see it over Toronto. So you can see the colors of the nitrogen compounds, that they're darker. This color here is the one you'll start to see in the skies over Toronto. Now, these paper masks people are wearing, they think it's going to help them. But what is smog made out of? It is made out of basically these things here. So let's take a look. They're gases that form acids in the lungs, carbon monoxide and carbon dioxide, which are lethal poisons, and carbon, which is a solid dust that clogs the lungs. What can these paper masks protect you against on this list? And just think about it. There's some videos on nitrous oxide in cars to refresh your memory about its use in a more entertaining way. There's some laughing gas comedy for you as a break from studying. Phosphorus is another element that's essential for life, and it's in all fertilizers. They actually show it as NPK to tell you, and it's in matches. So yes, fertilizer has to be stored carefully. It can provide the oxidizer for very big explosions and burns. Now, fertilizer is great until too much of it gets in the rivers, and we pollute the rivers with algae, causing algae blooms like you studied in grade 9. And then, of course, humans have this nasty tendency to weaponize everything we can. Phosphorus put on people is a horrid weapon. It burns people alive, and there's been many attempts to ban it. But one of the giveaway signs of phosphorus are these explosions here. Sulfur we played with, we got to see it. And nonmetals, when they burn, tend to form gases. Hydrogen makes hydrogen oxide, which is water. Methane makes water and CO2. So sulfur is actually quite similar. If you just change the C to S, it's the same thing. The difference is carbon dioxide is a gas that can make water a little bit acid, like soda pop. Sulfur dioxide can dissolve into water and make an acid that would skeletonize you in seconds. So it's much nastier. Sulfur dioxide smells like rotten eggs and burnt matches. You'll flee from it very rapidly if you smell it. So while it's similar to carbon dioxide, it's really nasty. Sulfur can have many forms, which is I like to show off in class. Here's the hot sulfur springs at Yellowstone, and you saw me go through these different forms like diamonds and charcoal, and we saw this on these volcano slopes. Now, the sulfur dioxide dissolving in these waters makes them horrifically acidic, as this poor young man who was dissolved to death in one of the hot springs. The moon of Jupiter, Io, is completely covered in sulfur volcanoes. You can see when shooting sulfur straight at the camera, it almost looks like a cat's butt if I drew a tail on it. And so what I did in the classroom in a boiling flask, there it is on a planetary scale, all the different forms of sulfur. And then finally, we did acids and bases. We did that cabbage juice, taking the pH from 1 to 14. And remembering 1 is acid, 1A, B are bases. So A and B, 1 to 14. The bases are high, okay, and the acids are low. And if you mix an acid and base like Drano and stomach acid, it'll just make salt water. That's all you need to know about acids. And then we'll get into optics, but I'll pause the video before it crashes out, and I'll add it as a second YouTube video.